right, we are live. Welcome, guys. Great to have you
Hi,
here.
Andreas.
Welcome. Hello.
Hey, yeah. Sorry, everybody else, for being 5 minutes late. I wanted to make sure Arockia can also stream to his channel on LinkedIn. Yeah. Welcome to the Breakfast Club. I have a tea. Santiago has a coffee. And Arockia, do you have something?
Sorry, I forgot to bring mine. Probably next time I will be prepared.
Well, for us here, it's 11 a.m., so you most likely had your tea already or your coffee.
Yes.
Yeah. Welcome, everybody. I already see the first few people here in the comments. If you have comments and questions to us, let us know. Santiago and Arockia and I, we are doing the coaching at learndataengineering.com for engineers to get better at data engineering, to make that next step. And we're doing these weekly. The last 2 weeks were a bit difficult, but today we're back and we're talking about design patterns. I think generally the design patterns is something that is important, or patterns that we see is something important, especially for beginners to understand these. Yeah. We talked a bit about what we're going to point out. Does somebody want to go first?
I can go.
Sure.
I usually tend to try to learn by doing, and also in this case, I try to use the framework. We already talked about that in previously chats in here in the Breakfast Club. Um, but it's important to know where are you using your pattern in the whole data life cycle. And for me that was something super useful to decouple all the parts in the life cycle and try to tackle some of them by learning, like, I don't know, reading and practicing some of these patterns. And as in the data life cycle, the first step is the ingestion. I came here with kind of a really good pattern that is useful, and I think it's widespread adopted in the industry. That is the incremental loading.
Mm.
And yeah, it has it pros and cons, obviously, like every pattern. Like in this topic, there is nothing that fits all the requirements and everything that we will need in the scope of data engineering. But this one is kind of a good one because you can use it for continuously growing data sets. Like you can have a delta column that is usually a column with like a timestamp. So in this case, you are going to filter by that column and ingest the data that is after the latest data that you ingest before. So it's kind of batch fields, but you have already your data in your data set. You go to this column, you say, hey, I had data from yesterday, so now I need to ingest new data from today. And usually the main kind of challenge there is with the hard deletes on the source system, because as you are looking for like new data, if some previous data is deleted, you need to tackle that in a different way. And also with the backfills, that is another issue there with or challenge, not issue. But here with the hard deletes, sorry, perhaps you need to like tackle that with a flag or something. That again, you need to have a good soft skills communication with, if you can, with the software engineers that are on the like uh, preparing and sending you the data, so you can tackle that issues. But yeah, That is a good pattern to start with.
I'm guessing a lot of people have this problem. So I would be interested for everybody else. If you're in the chat, post about Arockia. Have you been running into that problem?
Um, yes,
pattern?
yes, kind of. You mean this idempotent processing, right? Just not processing duplicate. I mean, pipeline failed. So it is there in every of my project. So especially in the past 2-3 couple of projects where I was involved with this ETL stuff and development pipeline stuff. We always made sure that pipelines are idempotent. As like Santiago tried to duplicate
A bit.
or checkpointing so that we never in every project when we develop a data pipeline, we make sure that it is idempotent. This is something like the baseline. It is not nice to have, it is like mandatory.
Yeah. For me, like one pattern that I always see is, and that is something that I also try with the coaching students to do first, and I have stuff in the academy about this, is that people don't focus at first on the goals and on the data. They always try to go immediately into the solution, which I think is a big deal. And that's a pattern that people actually need to early on understand and implement to figure out, okay, what is actually my use case here, talk with people about the goals, because that will then lead the development, right? And so for me, the technical is not the first thing. For me, the first thing is always, okay, understand that, because then everything else will flow automatically, and you will understand, do you need incremental loads, or is that, I don't know, is that some data that is where it's not super important?
Yeah, that is super good advice for everyone. And usually the data maturity of a company is going to also lead, in this case of the ingestion, for example. Perhaps you are a startup, you are recently starting with data, and perhaps a full load is a better approach because you have the small data on you need to ingest. So data maturity and learning the KPIs you are wanting to use. For example, if you are going to build a dashboard or something different, like feeding a machine learning model, that is super important. Also, yeah, I completely agree with that.
Let's see, we have a few questions here. One here is, so I'm asking, in architecture of data nowadays, we have Kappa architecture that's serving real-time data at the foundation in terms of data management or change management. When upstream download is going to change, so it will be schema evolution. What? There's no real question here. Well, Kappa architecture, what do you guys think about the Kappa architecture? Is that an important pattern that we need nowadays?
Yeah, and also to complete his question, Andreas, I see his question in the comment. So his question is, how should we design Kappa architecture to be decoupling from the schema evolution? Okay.
Okay, they didn't show everything, or did it? Yeah. How should we design Kappa architecture to be decoupling from the schema evolution? What do you guys think?
This question kind of odd for me. So what does he mean by decoupling from schema evolution? Yeah, normally we have this data contract kind of stuff. I have seen in some of my projects. So where they make sure that the upstream or downstream systems doesn't suffer any like issues during the schema evolution. So here, yeah, for me, from what I have been seeing, this data contracts are like it's something like the API definitions, where the actual like parameters or the columns that you are going to have, attributes that you're going to have. So similarly, data like contract definitions now plays an important role. Um, to to keep the pipelines upstream and downstream systems running without any issues.
But also, I mean, also generally, like Kappa architecture, Lambda architecture. Like, what are you people using most? I think the Kappa is, I don't know.
Yeah, it is kind of fully streaming, I think. But yeah, it's like streaming stuff. But yeah, to be honest, in real life, in most of the project I worked, sometimes we worked on like near real time reporting, for business intelligence or like machine learning stuff. Um, but yeah, I have seen this streaming architecture very rarely, unless until it's very critical, something like credit card transaction fraud identification, something like that. In most of the use cases, like near real time or like batch processing, it's more than like sufficient in the practical projects I have seen. So the more we do streaming, it's kind of the more there is like complexity and development workload is being involved. For example, in one of the project they were using Kafka. So they need this streaming data, but not exactly the same. So they have to use this single message transformations in Kafka, and they have to sometimes group like aggregate the real time data based on time window in the Kafka itself. The point here is the complexity really increases. Yeah, of course you can do if you have resources, people, and budget to do that stuff. But yeah, probably like Andreas and Santiago, you guys have different like experience or opinions on this.
I mean,
Yeah.
I would say with this streaming, it always depends. Do you really need to run aggregations and so on directly with Kafka, or are you just using it as a, let's say, as a buffer, as a way of fanning out processing behind it, right? You have that one message queue where the messages or the data is getting dropped in, and then you have these 10 processings behind it. They all consume from it, and they do different things with it. I think that is a pattern that well, I used before a lot, and I've not been doing so much of like in-stream processing with Kafka directly. Most of the time you do this afterwards, where you then have Spark or something, or Flink, where you then do the transformations and so on.
Yeah, I agree with Arockia also, because usually the projects I have been working on, they use this pattern of PubSub. I tend to use a lot of GCP, Google Cloud Platform, and we use PubSub there for the message queue. You can enforce on PubSub the schema of the message of the payload you need there, kind of a contract. So in that case, we just grab some information from the events, like enforce the schema, and then use kind of a streaming pool with data flow. That is Apache Beam under the hood, and make the aggregations there. That was kind of a financial project I went into as a data engineer, and the other ones usually tend to be like using change data capture, so it's near real time, and that's more than enough. So yeah, I think that the problem of this of decoupling from schema evolution also is some new files, file formats also help with that. because we were talking with Arockia recently about iceberg, and with Apache iceberg you can like get this schema evolution, and usually also you can design a way of like ingesting these messages that come from a buffer like Kafka, RabbitMQ, or pops up to a NoSQL database. So you have flexibility there also with the schema. But yeah, it's kind of a wide question that we can go like in different places and topics about that. But yeah.
There's an interesting part here that is also a kind of a pattern. And the thing here is when you say real time in real world project, does this mean smaller than 100 milliseconds, or is it more flexible, like 2 to 4 seconds? And what people don't realize is basically the pattern of real time. Real time is a definition thing. It's not like it's always meaning the same thing. And so this can depend on the use case. This can depend on the definition in the project. What is the real time? Of course, when you think about it, you would say, okay, real time needs to be something super low milliseconds, but it always depends on the definition. So that pattern is super important to also question, right? So if somebody says, we need this in real time, okay, what does this mean?
Yeah, so we actually tell like, so I actually used the term when it happened, or as it is happened, the event. So anything other than that, if it is a millisecond or second, it can be a millisecond delay, then it is near real time. So again, as you told, it depends upon the definition each one have, but generally we tell like when it happened, when the event is happened or happening, we are capturing it as it is.
Although you always are going to have some sort of a delta in there with a few milliseconds, right?
Yeah, you can't really like. Yeah, it's again like highly contextual. It's based on the system we use or like how we process the events. But yeah, real time, like real time. But when we talk about seconds or minutes, then it is not even real time.
True.
Yeah.
True. Yeah.
Yeah, and I'm going to be bad with this, but usually when you talk with the stakeholders, it's never real time. Because when you go deep on that, you say, hey, I need this like every 5 minutes. So you say, okay, this is not real time. And usually it's like that, it's like everyone jumps into the trending topics. Like, I think that sometimes the stakeholders went into X or whatever social media platform and read something about, and I say, I want this, and then they come to you and say, hey, I want a streaming pipeline to make this prediction model like much better, and they say, okay, and you go deep on that, and like going back and forward like in the conversation, and usually it doesn't need to be like a streaming pipeline. But yeah.
I think, who was that? I think Ben Rogershon, the Seattle data guy, had a post a few weeks ago about this, that most or almost all the time when people say they need to have a real-time dashboard, they don't. And people build it and it's not never going to be used. So yeah, I think it was him. Yeah. I mean, this whole thing, it's also a kind of a pattern where people get confused sometimes when we talk about this, like batch processing, then we have streaming, and then we have event driven, right? And I think this kind of understanding of that pattern, what is batch processing, what is stream, what is event driven, that is super important, because sometimes people think it's event driven, it's streaming, which is not, because also a batch process can be event driven, right? But I think that that whole process or that whole pattern is very important to understand.
Yeah, and under the hood, you also need to, because there is another question there on the chat from later raving data, and also here in streaming, like it's important to define like the concepts of streaming also, because you're going to process the streaming data like from the event time, from the processing time. So there you can define what is later raving data and how you're going to handle that. If you're going to use like the letter Q, or you're going to use the aggregations, and instead it's like real important data. And in this case is also something that you need to talk a lot about with the stakeholders on what to do there, because sometimes it happens that you can run kind of a mean function on the data of the event, and use just the mean values or the max values, or perhaps you need to use a combined strategy on that for making the aggregation. So you can have the skeleton of the pattern in head and trying to apply that, but usually the theoretical part in practice is it's wild because it will depend a lot on the stakeholders, use cases of the business, and yeah, streaming is a tough one, but yeah, I think that that is kind of what I do there. Like try to go deep with with the use case, and think if it's good information that sorry for that, that is coming like late. Perhaps you need to add the minimum values or the max value, or perhaps drive this combined strategy on that, of getting both. And yeah, it's that is what I tackle there to answer that question.
I mean, but generally, on when we're talking about streaming, I mean, Arockia already said it's often too expensive. But is it still really still? Because when we think about platforms like AWS or GCP, you have these systems like PubSub or Kinesis, and then you have in the background, I don't know, a function or a Lambda or whatever you're running in, behind. Is that still that expensive? Because earlier, when you had to host your own Kafka and you had to host multiple servers and they were running 24/7 and so on, that was quite an expensive thing. But nowadays you can start fairly cheap on that, don't you?
Yeah.
Yeah, but sometimes you also need to get a lot of tweaking the configuration. I remember um, like the retention policy, for example, in PubSub at the earliest stages was only 7 days. It's good enough. But then when people want to be this kind of like sure no data is going to be lost, on make some replications, or perhaps store that on different cloud storage, or some places, you need to like design really well that, because then I know we have some. I ran into some problems with data flow, for example, with the windowing and the aggregations there, like windowing, decoupling, deduplicating, sorry, and usually you incur in like because of this of the auto scaling stuff. Sometimes if you aren't like properly setting up that, you can run into huge processing times and huge power, and also expensive cost on that.
Yeah, and also regarding this late arriving data, I have experienced a couple of things. Uh, so like one learning is from one of my project is they designed the system completely for event time rather than the ingestion time. And also like
Arockia,
in
Arockia, I think
in the project where I was like working with the team which
Arockia,
before.
I think you need to. No, I think you need to start from the beginning because you're breaking up today. I don't know. It looks like your Wi-Fi is weak
I
or
don't know.
something.
So can you hear me guys now?
Yes, now it works again.
Okay, thank you very much. I don't know what is the issue. So I'm using one of the fastest internet in Germany.
Well, the problem most likely is that it's in Germany.
Yeah. So like coming back to the point regarding this late arriving data, I was talking like how the event time is being used instead of using ingestion time of the events, so that you can track the events exactly. And I have also seen like in projects they were using this grace period or watermarking, so before doing aggregations. So you have to wait until the grace period is over to have this aggregations or final results or like whatever they are doing with the data set. And of course this idempotent pipelines again comes into role here, plus usually partitioning on on like dates or like time stamp is again, like very useful. You can like exactly in the in time partition, daytime partition.
Oh, okay, you're frozen again. Okay.
Yeah, I'm here.
Okay, yeah, because like the last things we didn't understand, I guess.
Yeah. When you talk about partitions, after that,
Partition, because I was
we,
telling like partitioning based on a daytime, because yeah, yeah. So I was talking about partition. So partition is like partitioning based on day, like, so that when there is a late arriving data and we have like event date over there, then we can like it is easy and it is also performant to put it in the exact partitions.
Yeah. I mean, it's always difficult if you want to run some aggregations at the, let's say, at the end of the day for some reports or something, right? And then you have data that is arriving 10 minutes, an hour late. Then you're running into trouble, right? The report isn't done right. So that's always a tricky part. Even if you have the timestamp in your, like if the timestamp matters, and if you're looking at the timestamp rather than when it's ingested and stuff, it's still a problem, and it's going to stay a problem, I think.
yeah, I believe in that
Yeah.
scenarios.
The key
You
here
need
is
to.
we need to.
Sorry, Arockia.
Yeah, sorry,
I think
Santiago. Please carry on. I
again.
think I am having a lag.
Yeah, no worries. I think in these scenarios, the most important thing is like, again, like have a deep understanding on the business and the use cases, and also say, hey, I have this grace period, as Aroka said, so I won't process anything that comes like, I know, 1 hour, 2 hours ahead of the data that I already processed. I mean, perhaps we can drop this data, this information, as it is coming like 10 hours later. So that is also something you have to define on this kind of pipelines.
Yeah, I still remember whenever there is a late arriving data in one of the project, they create this as an incident to identify potential root cause, if it is due to system back pressure or some kind of stuff blocking the events from entering on time. So yeah, this way you can easily not easily, at least solve the common issues of the late arriving data.
What else? What else is something that?
Yeah, so when we thought about this topic, data engineering patterns, so my thought was like, this data engineering pattern, this word started to get really popular, probably the past like 3 4 5 years, Andreas, I'm not sure.
Yeah, yeah.
So like, yeah, before that, basically, yeah, it was there, data engineering pattern was there, but we were doing something like ETL and ELT. So it's like transforming or cleaning up the data before like loading and like after loading, something like that. So then it came into like medallion architecture or raw refined business layer, where you have clearly categorized data into the different layers and run data quality tests accordingly. So yeah, I see it is kind of evolution in terms of words, but the theory behind it is more or less like the same. This is what I feel.
Yeah, yeah, it's true. It's sometimes I also get asked like, what's the difference between ETL developer and data engineer, right? Because it's a part of
Mhm.
what we do, and the concept itself hasn't really changed over the years. Same with ELT.
Yeah, yeah, and also in that front, Andreas, one thing I really like see the change is where it's like uh, the pattern how we access kind of traditional relational databases and data lakes. For example, we have in data lake we have this pattern called schema on read, which means we don't define schema beforehand. Yeah, it is nice, it is fast, but I don't know, people are telling it's like less reliable. On the other hand, like data warehouse schema on write, fixed schema, everything works great. But in the past few years, in some projects or in some personal projects I worked on, I have never seen or like never have any had anything to complain about schema on read. Yeah, for transactional database, schema on write must be critical, since it is like business critical data, something like that. So what is your take on this, guys?
I don't know, Santiago, what do you think?
Usually, I on data lakes, I use the schema on read also. I didn't have any like any business logic that I need to fix the schema previously that getting data into the data lake, or I don't remember, but yeah, I tend to use like the data lake as the source of my kind of bronze layer, and then like make the transformation for like integrating different sources on a silver layer. I tend to my kind of my preferred design pattern is that like ingesting data into a data lake because of different formats handling, and then integrate everything on a silver layer and enrich that silver layer with some sources or something inside the company that makes the gold layer usable for, I know, perhaps feeding machine learning models or dashboarding for like business intelligence. um, that tends to be my preferred pattern right nowadays, and it's still working. So I didn't need to look to something else right now, but yeah.
I mean, for me, the topic with schema on read, schema on write, and especially with data lakes is a topic where I'm always arguing that schema on write is also important for working with data lakes, because otherwise all kinds of stuff is in your data lake and you have like these folders or thing where there are files in there and it's like, what the fuck is this? Why do we have this in here? So it kind of still matters. It matters a bit less, but I think it still matters, just from a point of, okay, we need to organize this somehow. Somebody needs to be responsible for this. And also when you think of data catalogs, right, you want to, when you think about the lake house concept, you want to work with the data catalog that might have some evolution, but you want to be able to build kind of a data catalog for the stores in your data lake, so that you're still able to understand what is in there and not mix everything together and then you're screwed. So I think it's still important. It's just in a different way important, that it's not enforced on write, but you should enforce it on write still yourself to, like Arockia said, something with data contracts, right?
Yeah, again, Andreas, it's all because of the evolution of big data and like different like modern providers, like data providers. Because like I still remember in the initial stages of my career, the life was easy, in the sense we have SQL server or like Oracle, where we don't worry about data contracts or like infrastructure monitoring, for example, and so on. Everything was so fine, so smooth. Then comes this data lake, big data and stuff. The workload literally doubled. For example, one other issue is like data lineage. So when you have data lake, you have like data from different sources. So you like the business intelligence or something like internal analysts, they see a number, they would be like easily asking you, where does this comes from? Without proper lineage tools like dbt or something like at least internal lineage stuff, you cannot easily like find where does this data come from. It takes some time. And also one more thing is infrastructure monitoring. So in the earlier days, we don't worry, we just have a simple like stored procedure in SQL server which tracks metadata table and tells us like which procedure failed or like what to look after. But nowadays it is getting really complex, especially when you use AWS. Like for example, in like AWS cloud, you can have like one data problem. You can solve the same problem in 100 different ways using 100 different services. So like people are getting confused, architects are getting confused. So the problem is how to collect these logs and like manage the logs or find critical issues before it happens. For example, in this EC2 instance, when you have something like airflow or something installed, so there is no proper way to collect all these logs. We should use some external solutions like filebeat or something like that to pull these logs and and push it into CloudWatch, later take it into Grafana and so on. So again, like our like data engineering engineers work is becoming complicated every day. At least so now we have a lot of AI tools and chat. It is something like a drop of water in something like the fire, where we get at least initial answers. If we have any questions, we we are just pointed to some direction. I won't say right direction, so that we will take off from there.
I was remembering something about again I going back to the discussion about data maturity and like gathering really business goals, and on this thing of the data lake design, like for the write on or read, I have usually this problem that the business didn't define like the real metrics that they want to track, for example. And then I designed something to ingest data and get everything kind of smooth and working. And then they say, hey, we need this and this and this and this from, and you need to go back again to the ingest that is already working, change the schema, go back and retrieve the data, get the data quality. Sometimes you get a lot of data quality issues there. Uh, and then I say, okay, the data lake, I'm going to ingest the more that I can from the source, because usually in the future, it will come this question and they say, hey, now we need this column, now we need this thing. And if I already have it, it's just kind of a plug and play. And you can like still work on that pipeline. That is usually some approach that I know is not the best one, but I kind of anticipating what is going to come from the business side, and try to do that. But yeah, and also I started with data engineering with Airflow. I remember it was something about Daxter and Mesh in the in the field of orchestration. And now you have a lot of tools. Like this is evolving so fast. I have this kind of mind map. I don't remember who had done it, but you say like the evolution of the tooling from one year to the other is like it's make pixels of tooling that you need to zoom to get everything that is inside that mind map. And usually I try to say to everyone that is starting that you don't have to feel overwhelmed about that. Just like pick a bunch of tools that works, and try to go deeper with that, and learn what is doing, what are the like the usually the use cases for that. And yeah, just use that tools a lot that you can feel like comfortable with that, and that's it. Then the concepts are the same. You can move from one to another if you have the fundamentals on that. So and one thing that I already chat with another people on this, but what do you think about data mesh that we are talking about, this lakehouse data mesh, the new kind of trending topic?
Yeah. I mean, I'm not. I think I mentioned this before. I'm not a super fan. I mean, I think it's mostly marketing stuff. Maybe Arockia has a bit of a different view on that. I don't know. The whole thing is data mesh.
Yeah, for me, like my understanding is like it's kind of decentralized, like data storage. Say for example, if in like big companies, they are still doing it. So like each company, each team or no domain, they have their own kind of data warehouse. I don't know, you can put it as like data mesh, but again there are like pros and cons. The cons is like, you can, it's not like single version of truth. So always there are fight between different teams, like why we have this number, why you have that number, and we spend countless like hours in meeting and stuff, and like lineage
Yeah,
tracking.
but
So this is the drawback.
I mean, yes, we have silos in many companies, in many departments. It doesn't need to be a huge company. You will very often have silos. And then you say, okay, that's bad. We want to make it so that we can access each other's data and we can process each other's data. And that is, I mean, logical. You want to build this, you want to empower people to use the data from other departments and so on. But then saying, oh no, okay, now we have a data mesh and that's, it's meshed and everything can be used together. And it's like, yeah.
Yeah, And sometimes, yeah, sorry, I interrupt
no,
you, Andreas.
no, I mean that's
Sometimes,
it.
with this, you also put a lot of effort on the policy tags, for example, because you need to design like that super well. Uh, I know sometimes you have some uh, super important data that is secret for the company, and only a few people can access that. But then you have to include this on the data mesh, and then you put like every policy tag on that data, and you have it there, but you cannot query, you cannot see it. And again, it's a data mesh, but you can use that data. I believe this comes into play when uh, in the early stages of machine learning, like the old machine learning right now, because sometimes like the data scientist has these features built for each model. Like it's the same data but replicated and just perhaps the same columns. And again, this is all about data maturity in a company, because you can tackle that, like building this feature store. If you have more data engineers in your company than data scientists, and build this, yeah, usually it is start all the way around. Like they hire a lot of data scientists. They start like getting data and modeling, and then you have a data swamp on fabricated features or feature stores, and then another developer enters in the company and say, hey, we need to tie this up and deduplicate the data and make this single source of truth. And you have to tackle everything. Go gather all the information, go with the data scientists, go with the chapters if you have different kind of departments, as Andreas said, and try to consolidate everything in one place. And then again, they say, hey, I can share this information, but at least this column, or I know this area, if it is a multinational company, we don't need to share across countries. So
Mm,
again, it's
it's difficult, yeah. It's sometimes it's really that, right? In larger companies, you can't. They don't want to share their numbers with a different country, although it's the same company. They're they're there in Europe, and the others are in Argentina, and the Argentinians are not allowed to see the numbers from there. It's like, ugh. But one thing I want to not forget, and I want to come back to, because Arockia was talking about data lineage. I think the whole pattern of, okay, we're implementing data lineage into our systems, and we are using stuff like DBT, and that's our one, like, or it's treated as that is the solution. I mean, it's data lineage is one of the most difficult things, because like just having one tool like DBT, yes, it's very good if you're running everything through DBT, and if you have your data in, I don't know, in the warehouse, in the data lake, and you do the processing from the data lake to the warehouse, and you silver, gold layers and so on. But DBT will not know what happened before, right? If some other tools are doing some other things, then you're again screwed. And that, I think that is one of the big problems, that some people think there is this one tool that does it all, but it's like, it's always, you have that small visibility, and then when you look outside again, you don't know it anymore.
Yeah, exactly, Andreas. I completely agree, because it is really difficult, because we have a stage called a raw, or like bronze layer in medallion architecture. So this is just for dumping the data. So in like mid-size or big companies, even like startups, they really don't care about identifying the schema in here. Like categorizing the files. So they just care about having the data in raw area, then we can decide later. Like some other engineer from other team, maybe a contractor, in the meantime he develops a reporting system. There are some critical numbers on that. So this is how it is getting complex. I actually don't know what can we do here to implement some standards. As you told, DBT is not the only tool. No, we cannot use DBT for like everything, for every process or every stuff out there, even though in the same company. So what do you think? How can we kind of generalize, or kind of force, or kind of set mandate to do this
It's a good question.
stuff? Lineage.
Because I think we need some tool developed here, because like a lot of people think always about the analytics use cases, right? And you talked about basically everything gets into the raw data lake, and then it gets processed and so on, and somebody does reports. Yeah. But that's only one part, right? Then you also have the transactional part, and in that transactional path that basically often runs parallel to the data, there you also have some kind of lineage. Something happens in there, right? Mm-hmm. And even if it's just like some cleaning, some combining of data sets to then put it into the right data model at the end, you have that. But then these two, they don't talk with each other.
Yeah,
right? You might have a solution for the transactional stuff, and you have a solution for the analytical stuff. So I don't know. I don't know if there's a good solution on that.
Yeah, it is always kind of like a manual work. So then when someone asks about lineage, because that's what most of the time in like data intensive projects that keeps us busy. Someone, some people from top management or the C level suddenly asks for explanation of this number or the lineage. Then we spend hours or even days to find where do we get this data. So I have worked on such issues in the past.
It's annoying.
Yeah, my main takeaway from today is like every business has its own difficulties, and for me the most important thing is try to have this wide open communication channel to go back and forward with everyone, and don't tend to be like applying a solution that fits every company, because data maturity is a big issue there, and you can like tend to apply something for a super huge company, and you are working now in a startup or a small one, and obviously it's not going to be the same budget, the same volume of data, the same frequency of data, and you need to like surf the wave there and see which pattern is the best one for that moment on that company. And I felt like completely sad when I was preparing the cloud architect certification, because the first paragraph on the study material says you need to be always architecting, and every 2 years your architecture probably is going to be rip and replace. And I say, no way, I'm like putting a lot of effort, reading, learning to do this, and in 2 years this is going to be old, this is going to be something or perhaps some parts I need to improve. And I say, yeah, that's the way it is. So find the solution that worked for today and completely meets all the SLAs and SLOs, and then run away.
Yeah, but I mean, that is how it is. You need to stay in a way open so that you can improve. But sometimes a complete shift from one platform to the other is in order. Sometimes because of company policies, sometimes because there's a better alternative. It's just how it is. I mean, that's how it is.
And here I also completely agree with Santiago. The data engineering patterns, when we talk about it, it always, like motivated by the projects and the SLAs. Like mostly, as a data engineer, we always try our best to implement this, pattern. I mean, data engineering patterns or best practices. But at the end of the day, SLAs and like delivering data or running something smoothly makes like more importance than like following some predefined patterns. And again, I mean, concerning the data engineering learners or someone who think too much about patterns, I would strongly recommend to like strong your foundations on ETL, ELT, and nowadays this medallion architecture, bronze, silver, gold. And then some concepts like why batch processing, why stream processing. And now the latest thing I see everywhere is like change data capture. So I would also really recommend to learn about it. Especially there is this tool called Debezium. It is used with Kafka. It is mostly used everywhere. When other than the proprietary services like Kinesis or some other like event processing systems, this Debezium is most commonly used for CDC. So actually, these kind of stuff will, and also building idempotent pipelines. These important points, would like make someone like a new data engineer to shine in the interview, to stay like competitive with other data engineers out there.
It's true.
Sorry, there is one question on the chat that we didn't answer, and you again mentioned the concept of idempotent. Can you tell something, a few words about that?
Where was that? I hear above here.
Uh,
This one.
uh,
But quickly, we need to. I want to get to Manuel's comment, and then we are already an hour in.
Oh, okay. Let me put it quickly. This is idempotent. So how many times you can run the pipeline? How many times you want? It should return the same result. It should not generate any duplicate. So to put it shortly.
Different results.
Yeah.
I want to, at the end, I want to come to something that I think, because Manuel also has a nice pattern here that I always try to run, is like to do checks upfront, like that every subsystem, every part that you have tries to assure that the data is correct, right? Then it's at least, he says, then it's at least likely that the output will be as expected. If in your pipeline, I don't know how many steps you have, that you try to implement some kind of basic checks. And I think that is a good pattern to actually do.
Yeah, always checking at source is nice, but again I really wonder how can we make a pipeline deterministic when we have like several steps in that pipeline. Yeah, it is again and then subjective of the implementation. So usually in like every major like checkpoint or step in the pipeline, it is suggested, recommended to do some critical test. At least if you notice some critical value that is really essential, or an attribute that is really essential for the end user, just implement tests on it. At least the basic tests where you have something like an enum, where you define like allowed like value, something like that, and use it in every phase of the pipeline. uh, I won't trust pipelines at like something like what you give is like what you get. It's not like that in my case, at least in every project. So yeah, issues can happen anywhere. The key here is just identify like every time where issue happen, and try to like like kind of like answer it, or try to give some solution to it. So this is how you improve.
I mean, of course, you cannot always test for everything. Like if there's too much or a lot of data being pumped through your pipelines, it doesn't make sense to check each value if the value is correct. Like that, it's not possible. but checking in different steps, like in an API, check if the schema is right. Right, this way you already have the first check, and then, as you said, think about, okay, what problems can arise during the processing, and then check these things in every step. That then helps you to get to a good output, instead of just, okay, we're just running the data through and let's see what happens. Is not really good. Yeah, we need to come to an end here. We're already an hour in. There are more questions. One thing was like there's so many terminologies and technologies. How can a person be confident in the skill set or learn everything? I mean, you don't need to learn everything. There are certain, let's say, areas where the tools are always, where you can sort them in. I have on learndataengineering.com, I actually have a tools guide that has in columns the platforms and open source and vendors, and then in the horizontal, in the rows, has the different areas where the tools are, so that you can see, okay, which tools are actually doing the same thing. And then once you understand these patterns, it's actually pretty straightforward. It's on the main website. Yeah. Let's come to an end. Thanks, guys, for being here. Do me a favor, when I end the stream, stick around for 5 minutes. I want to quickly chat with you. And for everybody else, and everybody who's here, who's listening to this, if you want to get coached by Santiago, by Arockia, and by me personally, we have the coaching program on learndataengineering.com, where you can join us every week. In the beginning, we are doing a kickoff, and then you do a one-on-one with me, and then you can also join Santiago, Arockia, in their sessions, and mine every week. And this is where we bring you to the next step in your career. Right? And the next one is starting June 23rd. And yeah, if you have questions, let us know. Yeah. It was awesome, guys.
See you guys.
Thank you, Andreas. Thank you, Santiago, and see you later.
Thank you guys. Yeah.
Bye.